So now we're going to look at another type of equation that we need to know how to solve. You looked at solving proportions last year. We're going to make them a little more complicated, a little more involved, but proportions are all solved the same and not a big deal once you get the step or two that you need to know. So a proportion is an equation. A proportion is two ratios set equal to each other. So A is to B as C is to D. That is a proportion. A over B equals C over D. And the way that we solve a proportion, we use cross products. Sometimes the solution to a proportion is pretty evident and you don't have to use cross products, but a cross product will work for every proportion. So notice there's an equal sign here. That's important. This is an equation. This is 4 over 3 or 4/3 equals x over 6. There's an equal sign here. So what we do, we use a cross product. So you can draw in an x sort of across the equal sign. You don't have to draw that in, but they might help you. And cross products means you multiply the things that are across from one another in the equation. So the 3 is across the x from x, and 4 is across that x from 6. So we're going to say 3 times x equals 4 times 6. Now you're not going to have to write that part every time, but that's what we're doing. This product equals that product. So then we say 3x equals 24. Then it is an equation. This is a one-step equation. We're going to divide both sides by 3, and x is 8. We do the same thing on the other side. We multiply across using that x, the equal sign. We do 2 times x equals 3 times 4. That is 2x equals 12. You can, if you see this part right here, you can start right here. So just 2x, 3 times 4 is 12. You don't always have to write this step. Now it's a one-step equation. We're going to divide both sides by 2, and x is 6. As with most things in algebra, things start to look a little more complicated, a little more involved. So this is a proportion. We have the ratio 2/10, and we have the ratio 4 over n plus 5. Remember, these are division bars, right? So 2 divided by 10 equals 4 divided by n plus 5. What's important here, something that you need to always remember, is that the division bar is a grouping symbol. So this n plus 5 is in parentheses. We don't normally write it, but we need to know that that's there. So here are our steps. The first thing we're going to do is we're going to use cross products. So we're going to draw our little x in. We're going to say 2 times n plus 5. And notice that n plus 5 is in parentheses because it is a term. It goes together, equals 10 times 4. So that's our cross product. Step 2 is to distribute if necessary. A lot of times with an algebraic proportion, you will end up with this distributive property. So we're going to say 2 times n, that's 2n, 2 times 5 is 10. Then the other side, 10 times 4 is 40. After that, you're going to get some sort of equation, a one-step, a two-step. You're going to solve. So here I'm going to subtract 10 from both sides. I get 2n equals 30. I'm going to divide both sides by 2, and n is 15. Remember, we should be able to plug n back in and get a true statement. These can look all sorts of ways. Here I have y minus 3 over 2 equals y over 5. The y minus 3, don't forget, that is in parentheses. That division bar, this division bar is a grouping symbol, so this is in parentheses. So I'm going to do my cross product. I'm going to say 5 times y minus 3 equals 2 times y. So that's my cross product. Then I'm going to distribute. 5 times y is 5y. 5 times negative 3 is negative 15 equals 2y. So now I have a variable on both sides. Notice I have a 2y on one side and a 5y on another. This is one of those situations I told you about that you don't want to move the smallest variable, because if you move the smallest variable, you end up with 0 over here on the right side of the equal sign, and that can make you miss things. So here, since the 2y is by itself, I'm going to subtract 5y from both sides. It just means I'm going to have a negative. I've got a negative 15. Notice that minus sign there. 2y minus 5y is negative 3y. I'm going to divide both sides by negative 3. And y is a positive 5. All right, here's another one. Notice I've got 2k minus 3. That's in parentheses. K plus 9 is in the denominator. That's in parentheses. So I am going to use cross products. I get 5 times 2k minus 3 equals 3 times k plus 9. So I have two sets of distributive property here. 5 times 2k is 10k. 5 times negative 3 is negative 15. 3 times k is 3k. 3 times 9 is 27. I have a variable on both sides. I can move my smallest one this time. So I'm going to subtract 3k from both sides. 7k minus 15 equals what? 27. I'm going to add 15 to both sides. And 7k equals 42. I'm going to divide both sides by 7, and k is 6. So that one was a little more involved, but notice it's the exact same process. Cross products, distributive property, and then whatever kind of equation you get, a two-step equation, variable on both sides with distributive property on both sides. Solve it, and there you go. All right, on this side of your notes, I have 4 problems. I want you to try these problems on your own and then check your answer. I'm going to do 2 and then give the answer, and then 2 more and give the answer. So I'm going to work this problem and this problem first. Then you can turn the video back on, check those, and then you can check the 2 at the bottom of the page, okay? So at this time, pause the video, try these 2 problems, and see if you can get them correct. Okay, the first 2. The first one, I got a funky little answer. I rechecked my work, and I think I got it correct, but I got 43 over 2. You can leave it that way. Since it's a terminating decimal, you can go ahead and change it to 21.5. I am fine with the improper fraction. Since this terminates and is a nice decimal, you can change it to a decimal, but you don't have to. Then the second one worked out a little nicer. You had a variable on both sides, and I got m is 3. Okay, pause the video again, and now try the 2 problems at the bottom of the page. Okay, these answers worked out kind of nicely. Also, the first one ended up with a variable on both sides, distributive property on both sides, worked out kind of normally, and n was 7. Second one, same sort of thing. Just remember that 3p minus 2p is 1p. You don't have to write that 1, and p was 17. One thing I want to show, the way you could check this, this one here where p is 17, if I wanted to check it, I would say 17 minus 5, right here. P is 17, so 17 minus 5 is 12. 17 plus 1, if I plugged it in the denominator, is 18, and 12 over 18 does in fact equal 2/3. 6 goes into both of those, and that would simplify to 2/3. Okay, so that is how you solve algebraic proportions. If you have any questions, ask them, and you're ready to do your practice.